All right, guys, today we got histograms, talking about histograms. If you can't read cursive, it says histogram. All right, what is a histogram? Histogram is a graph consisting of bars of equal width drawn adjacent to each other, unless there are gaps in the data. The horizontal scale is the classes that we talked about with frequency tables, and the vertical scale represents the frequencies. The bars correspond to the frequency values. Basically, I put down here, just a graph of a frequency distribution. You know, we spent the last 2 days doing frequency distributions. This is how you graph them. A couple of examples here. Let me blow this up for you a little bit. First one is for the low lead group again. So, you know, we did a frequency table of that yesterday or the day before. So that's what the histogram would look like. And also over here we got the full IQ score. This was just the, this one is the histogram of just the frequency table, and this is the relative frequency histogram where they use percentages. And if you look at those two, they have the same shape and the same size. And the only difference is the second one is using proportions or percentages instead of the raw numbers like the first one does. So either way works fine. You get the same result either way. Need to make that word go. There it was. Our main job is going to be to interpret them because we're going to use some software to draw these for us, which is very nice. The bell-shaped is what we're going to be looking for the most. If we can find a bell-shaped, and this is what we're looking for. It doesn't have to be exact. If you can see like they drew a bell-shaped curve in black on that picture right there, kind of going up through here and then back down. If the data is close to fitting in that, we're going to call it bell-shaped. Notice the word roughly. If it's roughly bell-shaped, we're going to call that a normal distribution. And we're going to use normal distributions like crazy as the year goes on. So that's what it will look like right there, normal distribution. Here's some characteristics of normal distributions. First of all, when you look at your picture, the frequencies increase to a max, then they go back down. The graph has symmetry, where the left half is roughly a mirror image of the right half. So it's going to peak in the middle, and then both the left and right hand side should kind of be close to being mirror images of each other. Very rarely will it be perfect, but it could be. There's also less, and that's subjective. Like somebody might look on one and say, well, gosh, that looks symmetric to me, or that looks like a normal to me, and somebody else may say, I don't know. The good news is there are ways coming soon that you can determine if it's normal without having to be so subjective, just looking at a histogram. If it's not normal, it's either going to be uniform, skewed to the left, or skewed to the right, one of those three. And I'm going to show you what those look like right now. First of all, this would actually be bell-shaped. You know, if you do the curve like this, it fits it really nice. So that would be bell-shaped or normal. We're going to start calling it normal distribution. This is what uniform looks like. A uniform is basically where all the bars are about the same height. If they're almost exactly the same height, that's called uniform. They're all the same. These are backwards to me. When I really think about this, I always think of it backwards. But skewed to the right means we're going to call it a tail. The tail of the histogram kind of goes to the right. More values kind of fade off to the right than they do to the left. So skewed to the left is just the opposite. It's going to have more small values over here, and they come up, and that's called skewed to the left. Wherever the tail. This part's called the tail, and that's going to be important later too. But that's the tail. The tail is that side. Wherever the tail goes, that's the way it's skewed. That's the direction that it is skewed. A better test probably to see if something's a normal distribution is called a normal quantile plot, or sometimes called a QQ plot. And I'm going to be honest with you, we're going to use either our TI-84s. Please bring those with you. You need your calculator and your laptop. We're going to use software to graph those for us. But here's the deal. When we graph those, if the plot is reasonably close to a straight line, then that means it's going to be normal, a normal distribution, which means we can do some things with it. I'm going to show you a picture of a couple of those. Here's what one would look like that we consider normal. See the points in that distribution or the graph close to a line. They're not hardly ever going to be in a straight line. But there's also no other, if you read what it says down here, I don't know why I just did that. There's no other systematic pattern that's not a straight line. So look at the next one. This is one that's not normal. Obviously, that line, you got a ton of points kind of coming up through here, and it kind of goes this way. So definitely not normal. They're not even close to a straight line. And then this last one, they drew a straight line, but here's the deal. There's a pattern that is not a line. If you look at the points, it's kind of going kind of going in a wavy type pattern, kind of going there and back up and starting to go again. So if it's a pattern, some kind of, they call it systematic. If there's some kind of systematic pattern that's not a line, then it's not normal. It has to be close, reasonably close to a line with no other pattern visible. That's how you can tell with a normal quantile plot or a QQ plot. And we're going to work on doing those with technology tomorrow. So please, just a reminder, bring your calculator with you. We'll knock these out. Hopefully that wasn't too bad. Again, histogram, just a picture of a frequency table. So this week's been like frequency table week. And I'll see you tomorrow. See you, bye.